We're going to continue with our next speaker. A lot of you might have heard from Jolla, maybe already, and the operating system Sailfish. Carsten is actually going to give us a bit more details of the inner workings. Carsten, go ahead.
So just checking the audio, is this actually going through the speakers or not at the moment?
No.
No? Crap.
Is this better? Okay. So, just to tell a little bit about myself, my name is Carsten Munk. I'm Chief Research Engineer at Jolla, and well, this practically means that I look at all the stuff while everybody else is doing the work, to be honest. So, we started Jolla in 2011. Many of us have a quite solid background in the open source community, mainly from the Migo and Memo.org communities. And this is the next part is marketing message, just for good measure. This means that we're quite strong believers in creating meaningful things together with the community, whatever that means, but I'm sure that you do know what that means. We are a company of roughly 90 people, not only in Finland and Hong Kong, but many people work from their home in their respective countries. So, as a company, we've been on quite a journey to get at where we are today, and one of the results is that we produced a mobile device. I'm not actually going to bore you by going through the specifications of the device. You can see them perfectly fine up there. But this is the device that today is in the hands of consumers, and if you're interested in getting one, you can go to jolla.com and go from there. So just out of curiosity, how many in this room has the device already? Okay. So, if you don't have one, but you would like to play around with one on a little deeper level, and you actually have Wi-Fi working here, and you have an IPv6 compatible stack, or whatever, you can look at these instructions and try to access the device. Don't reboot the device, please. Or you can try to approach one of the people who just put up their hands and ask them what they actually feel about this device, because I can give you a lot of marketing talk and it's not going to be very nice and it's going to be really boring, but you should listen how the user feels about his actual device, because that's actually what matters. Otherwise you can come to me afterwards, the talk, and I can give you a demo. So, one issue that is probably fairly important for many people in this room is the topic of tinkerability of the device. It's also a topic that's very important to myself as well, because I don't personally buy devices unless I know that I can hack them. That means I can install my own kernel, I can install my own file system, and I can boot the damn thing. So you can kind of consider this a declaration of hackability for the device. We have some sad situations. We can't provide factory images for the device because of third-party restrictions, etc., etc. But the rest of the setup is quite good. You can get full root on the device if you want to a developer mode. You can unlock your bootloader as of the update of yesterday. The kernel source is available. The Wayland driver is sadly closed source at the moment, but that's because it comes together with a kind of combination that we got from the ODM, and there's an open source version of it available that is a later version that actually works on top of the kernel as well. We're just not able to take it into use at that point. And since we give people the ability to get full root on their devices, that this kind of power comes with responsibility, and for some reasons it might affect your warranty status, just general thing, but don't get anything to burn or anything like that and you should generally be fine. So another part of the journey that we've been on is that we build a mobile operating system. This is a mobile architectural diagram, and it has absolutely no basis in reality. Because, as we all know, what this really means in practice is it's a bunch of components. It's things like systemd, core utils, conman, Ophono, etc. It's supporting tools like SDKs, build farm software, QA tools. And the kind of key points I like to bring up of SailfishOS is that it's a systemd, core utils, edlibc, RPM, libzip, Wayland and Qt5 stack that is able to leverage existing hardware adaptations, as in the software that talks to the device hardware. And I'm not going to bother you with the details of all this, except for very few topics, because you can look at the different terms, Google them, so you might know them in the first place, etc. So, as some of you, if you have followed Jolla's story a little bit, you knew that back in April, we got into the kind of interesting situation that we had to change the entire reference design that we had built our device on. Last year, we were in this exact dev room, and we presented our Qt4 X11 base stack. And because we had to change this our system on chip, this meant that what we had thought about for Sailfish 2.0 became Sailfish 1.0. And what this meant was that what we had thought about for Sailfish 2.0 suddenly became 1.0, and my summer holiday was destroyed. We switched to some new technology called libhybris, which I'll be explaining a little bit more about in the end of the talk, where we are able to leverage existing Android hardware adaptation. We switched away from X11 because, practically speaking, it wasn't possible to get X11 and OpenGL drivers and so on for interesting hardware, and we switched to Wayland. But compared to some other approaches in the open source ecosystem, we didn't decide to reinvent the entire thing, write our own display server and so on. So that had the benefit that we could develop the user interface using existing components that already existed today. We could combine VirtualBox together with Mesa, LLVM for software rendering, Wayland, existing compositors, and then develop the hardware alongside alongside that we were developing the UI and the entire stack. And the result of this you can see in the kind of following slides. It's not mock-ups, it's not cardboard applications that are just screenshots when you enter them. It's a real operating system that, as you can see, many users are using today as their daily devices. So with this stack that I mentioned just before, we built a quite beautiful UI, and because of the low resolution you can't exactly see all the details. And now I'd just like to talk a little bit about how factually to contribute to SailfishOS. Just a moment. And there's a couple of challenges in this, because there's many different forms of contributions beyond code, and I'm sure that most of you know that. There's things like ideas, bug reports, enhancement requests, constructive criticism, translations, hugs, artwork, community support between each other, virtual keyboard layouts, events. Some of you might have visions about how you would like the device to be, etc. Hardware hacks. And what we took that and we did something a little different than you would normally expect from an open source project, is that we didn't open up Bugzilla. We didn't open just feedback forms for end users. Instead, we went ahead and took an open source piece of software called AskBot, which is where we put it on togetherjolla.com, where we try to kind of combine the aspect of user issues and being able to kind of co-create together with developers, different functions of our company, users, and most, if not all, of all of the companies participating in the site, even our CTO, our UI designers, and so on. So it is something that makes you able to get in touch with the people who make your device and work together with them to make it better. And it might be a little controversial that we kind of ask people to add bug reports in this kind of setup, but it has worked pretty decently for the most part, because the kind of votes and the comments on this site, it gets taken straight into our product development process, that's our design process, and the output is then reflected back into the site again. And just for good measure, I'll take questions in the end of the talk. My own corner of togetherjolla.com is called the Skunkworks, after, well, if you don't know what skunk work is, it's kind of labs where you do strange kind of things, futuristic looking things, etc. And we kind of try to explore and discuss more wild topics in mobile devices. And we try to kind of evolve the ideas, do the things together there. And in order just to propose anything to this, you go ahead and ask a question, you tag it with skunk works, and those of us who are working full-time on kind of exploring the future, we try to explore the topic together with you. Now, when we're talking about co-creation, that doesn't only mean that one side is contributing. Obviously, it's both sides, not just the users contributing, it's also the company. So this is pretty much our open sourcing policy right now, is that everything except for artwork, trademark, look and feel, which pretty much means UI, stuff that we don't own, and stuff that has been written by things that we can't actually reveal to anybody else, or things that require copyright transfer, you can open source that, unless you get permission. So it's quite a flexible strategy, and we will be showing exceptions to these rules up here quite soon. This has also meant that we can have kind of avoided a lot of red tape in our development, as in, our developers haven't had to think about if they need to close source something or something like that. If it's anything but this, go straight ahead and open source it. And in the following slides, you'll kind of see this policy in effect. So, just for good measure, I had a problem with the resolution, so I need to show you a browser window. This will take 30 seconds to set up, because I couldn't get it to fit on the slides without it being completely unreadable to the rest of you, so just give me a moment. Okay, that's not what I meant by readable. So, I'll first start by kind of this is evil closed source at the moment, where we have things like our messaging application, our contacts, our settings, different things like, for example, our store. That was not supposed to happen. Good. Our QML components, etc., etc., etc. But at the same time, if we go a little further to the left, well, at the same time, if we go a little to the left, we have all the things that we have contributed into open source or are using. So, of course, we are using quite a lot of the existing Migo.com stack that was, but we have also significantly productized quite a lot of these components. These components are open source. So this is the middleware, where, for example, we have an example like the framework Lipstick, which is the framework we use to make our home screens, which means that it's extremely easy to build a user interface, our home screen, for Wayland compositors using QML, using this particular framework, for example. So we give all the building blocks to do all the fun things, and then hopefully we'll be open sourcing more as we go. And of course we have the kind of core, which is Qt5, glibc, GCC, BlueSet, dbus, bash, core utils, command, etc., etc., etc. So now back to my slides. So, that was the slide I already showed. So, I'll be the first to acknowledge that it's a little bit unclear how you contribute factual code to SailfishOS at the moment, because we are collecting a lot of different software components, just like the existing open source ecosystems that we had, that Git repositories and contribution places for example, let's say systemd, dbus, conman, ovono, etc. They're spread all over the place. So it is a little unclear how you contribute a piece of code to an open source project, how on earth does it actually get into SailfishOS? And this is something I've made it to my also kind of personal task that I should try to improve, but I certainly don't have any good answers regarding this today. It is my belief that if you see something like you did on the togetherjolla.com before, you can raise a question, you can raise a doubt, and then the hope is that through these specific goals, you can bring in people who know something about the subsystems, know about the designs, how things are supposed to be working, and then they can guide you eventually towards what components you have to work on, or not have to work on, but can work on, in order to improve this particular aspect of your device. So kind of focused code development based on specific topics. Because it is sometimes it's easier to involve multiple functions, like, let's say, designers, component owners, or God forbid that you need to bring in a product manager to do something, than just code. Because if you're operating, for example, on the UI level, it's much more than just writing the code. It's about having test cases. It's about having the ability to be fluent, 60 FPS UI. And that the designer actually thinks that is a nice thing, and it looks good in the implementation. And as I said, there's a lot that can be done to make Sailfish development much more transparent, and a lot more visibility into how code in the repositories you saw make it into SailfishOS releases. And we hope to get these in order soon, but I didn't manage to get this ready for FOSDEM to this time around. So, just diving in a little bit to some specific SailfishOS technology. Specifically libhybris, which is kind of, it's a deep down technology in SailfishOS, which enables us to leverage Android hardware rotation. I'm going to tell you how it works, and if you think it's a complete hack, you're probably right, but it works quite nicely. So, this is from Wikipedia, and it is pretty telling about the technology approach from libhybris. It's not perfect, but it's a little crazy. So, to summarize libhybris, it's basically the linker code from the Bionic C library from Android, ported to glibc environment, and a bunch of wrappers built on top of that. And what I did was that I looked at the source code and saw, well, a linker doesn't typically spend a lot of time talking to the C library, because the C library is not factually loaded at that particular point when the linker is running. So it's a very restricted little set of code, which meant that you could actually build this with GCC as glibc, and it worked. And this is pretty crazy, because as I said before, this is kind of a loss of all technical sanity and contact with reality. But it does solve a huge problem for those of us who are working alternative kind of emerging mobile OSs, which is it's impossible to find hardware if you want to use existing, almost impossible to find existing hardware that are things that people would factually buy at decent price points, that we can put our mobile OSs on. If you go to an ODM, you will get a reference hardware, sure. Next thing you'll get is not a Linux BSP with X11, OpenGLES working and everything like that, but you'll get an Android adaptation. And this is kind of a way for us to leverage Android hardware adaptations, so we have a much larger spread we can put our mobile OSs on. So, going down a little deeper, this is another quote from Wikipedia. In practice, if you want to load a shared object or library, you use dlopen function. Then you go ahead and locate the address of some ELF symbols, and then you have with dlsym, and then in order to execute those functions, you have to use function pointers. So my initial experiment with this was that, well, as I said before, I built the Bionic linker for glibc. I renamed its dlopen, dlsym, dlclose to Android prefix, because frankly speaking, it shouldn't collide with the glibc symbols. And I disabled all kind of dependency loading, as in if there was a elf dependency for libc so, it didn't load that, fair enough. I built a small shared object against Bionic, just simple function. I deal opened the thing, I made a function pointer to the elf symbol, and I tried to call it, and it worked. And just to kind of step up my amount of headache with this particular issue, it kind of seemed ridiculous that someone would go ahead and try to load Bionic and glibc in the same process as address space. So that's what I did. And for all intents and purposes, this should have crashed massively, but it continued working, because what just happens is that it maps the code into memory, and for the most part they don't conflict, except for a couple of problems where I have to give this disclaimer that problems in this particular case might mean significant technical nightmares. First off, Bionic and glibc has two different implementations of how they use the thread local storage, which is kind of per thread area where, as it says, they can store values and so on. Basically, if you try to go in and use the Bionic pthread methods in while still in glibc, it will completely corrupt the thread local storage or the thread descriptor. And this meant that we kind of had to go in and make a bunch of wrappers. And the reason why we could make a bunch of wrappers is because we, the linker, we decide where the symbols get resolved to. So for example, if I have pthread mutex log in my Bionic shared object, it would then be able to be redirected to my own little wrapper, converted to something glibc-like, and voila, things start working. And other fun things is that when you're doing a system call, there's again a per thread variable error. And of course, these are two different places in Bionic and glibc, so we had to go in and make methods for hooking this. And we also had additional fun things on ARM. Bionic is using soft float ABI, which means that when we're calling a procedure and we have float arguments, this means that the arguments will go into the integer registers instead on the soft FP. But in hard floating point, this means the arguments will go into the floating point registers. So this meant that, for example, if we had a library like OpenGL, which using a lot of floats, we had to go in and make wrappers for these that convert between the two calling conventions. So what we did is that we went in and patched Bionic, because with a bit of tricks, then we can choose to use another Bionic, because, well, Android doesn't really need it at that point, and we ended up with quite a nice set of wrappers that actually just work. And the device that you see today are running on top of this. Well, in the start it was a hack, now it's a little better. And the applicability of this is quite clear. We can kind of access the all kind of well-known, well-defined Android hardware adaptation interfaces, OpenGL, that kind of stuff, and we can build a mobile OS stack on top of it. It's quite simple. Go and load the EGL library, make a function pointer, call it, and we make wrappers based on this because we know the API in the first place. And we've been successfully able to do this, and when I say we, I don't mean Jolla in this particular instance, but I mean the libhypers team, or whatever we're calling it, where we've been able to access things like Android Squalog, OpenGLES, NFC, all the hardware adaptation layer stuff we can get our hands on, OpenCL, Surface Flinger, which is Android's compositor, OpenMax, camera, hardware composition, etc., etc., etc. Now, another thing that I've done is Wayland on libhypers. So this is something I've already tried to explain in my blog, which is mer-project.blogspot.com. Because, well, we want to put Wayland on top of Android hardware adaptations because Wayland is cool. It's thought through. It's already quite well tested on desktop side, and best of all, we didn't have to reinvent anything. So how, in practice, you could do this with the existing Android drivers is that what we can do is factually we wrap libgl, but one good thing about the Android graphics stack is that it's modeled around when you are making a Windows service with EGL, or taking a service into use for EGL usage, you pass what is called a native window, which is basically a structure indicating width height, hooks like queuing a buffer, dequeuing a buffer, which practically means give me a buffer I want to render into it. And this meant that we didn't have to go in and modify every single OpenGLES driver in order to get Wayland support. And I'll just explain in a moment how that is possible. These particular hooks, like QBuffer, DQBuffer, is using a type called a native window buffer, which contains a so-called Android native handle. Now, if you want to allocate a graphical buffer in Android, you have to use the aptly named gralloc. And what this gives you is native handles, which is practically file descriptors, as you know, file descriptors are factually kernel objects, integer values. And because they are kernel objects, this means that you can share these file descriptors between processes through a process called file descriptor passing. And then it is possible to then take this particular graphical buffer and register it into your context of your kind of GPU context, and then take it into use. So if you need to get Wayland to work on your stack, you have to have a EGL stack that speaks Wayland, as in it takes a Wayland window in this particular case, which is VL EGL window in this particular case. And we can do that because we wrap EGL, so we can go and hook every call that goes to EGL window, create window service. We can then allocate our buffers when we get the request of DQ buffers. And we can then share these buffers through file descriptor passing, and then in the end use the buffer as a texture within our OpenGL scene graph. And well, then we obviously, since we have Wayland's amount of control about the buffer, the state, visibility, etc., well, we have a compositor, a GPU accelerated compositor. So that was quite easy to do in the end. And some of the kind of arguments that was made against Wayland originally on embedded ARM devices is that it doesn't have server-side buffers, which some stacks require. So supposedly were requiring, but we've had libhybris and Wayland on practically every SoC GPU that we can get our hands on, and I've not seen any kind of requirement like that so far. But it is worth remarking that sometimes server-side, as in compositor side, buffers may be useful for example, sharing the wallpaper, the icons, that kind of stuff, to keep down the memory amount. And libhybris today, initially it was open sourced according to the open source policy you saw before from Jolla. So it's a technology that we made in the company, well, I made in this particular case. It's one of the few projects where we have multiple competing solutions working together towards a common goal. We have SailfishOS, we have Intel/Tizen, we have Canalco/Ubuntu, OpenVRBOS, and many others. We've tested on many different versions, SoCs, architectures. We have a Git repository, and we have a nice little IRC channel for this. So, since we are getting towards the end of my talk, if you're paying attention in the start of the talk, we were talking about that it might cost a little less if you paid attention to this talk. And it is possible to get a cheaper Jolla, 40 euros cheaper, under these conditions, if you use this FOSDEM 2014 code. And thank you for listening. Any questions? There's the free hat if you ask a good question.
Okay, it's not actually it's our little hybrids, but around build system Scratchbox. And one question is why is Scratchbox not using native, or why are you not using a native cross-compiler and using the Scratchbox?
Yeah, so the Scratchbox setup is that, well, first off, let me just rephrase tell the question again, that you're asking about why we are not using native builds and instead using Scratchbox, which is a cross-compilation framework. And the primary reason for this is that we need to be able to cross-build our applications. For example, our SDK, it has to be installed on obscure targets such as Windows or Mac. And this means that, well, we can't exactly hand everybody an ARM board to build our systems on. So that's first thing. Second thing is that while it is very nice to build natively, for the most part, it is faster to do the builds on a very strong and significantly multi-core x86 device server. So that's what we've done, where we can put a large amount of RAM. Native building is technically cleaner, sure, but at the same time we haven't seen any kind of ill side effects from doing so.
I was just asking about cross-compiling from without us. I think Scratchbox uses some kind of virtual machine.
No, it doesn't. It uses file system redirection, which is just as evil. But yes.
And my question was just about the cross-compiling without.
Okay. So the question is why isn't it? Well, it's using a virtual machine. Is it? Okay. Now I've got your question. But long story short, it might be using a virtual machine, but for 95% of the time, when you're doing a typical autoconf-based build, it will spend most of the time in existing host tools anyway. Mm. There you go.
You said using the Python you got and get hardware command working. So are you using any of the hardware capabilities to do layers of Wayland, like
So just to remember your question, I'll just stop you early. Long story short. The question was, are we using the hardware composer to actually factually actually take multiple layers of our UI using Wayland and compose these together with the hardware composer? In our current system, we're not. In Wayland, there is something called subservices. We are sadly on Wayland 1.1.0, which doesn't have subservices, but we would like to start taking subservices into account. The second problem is that hardware composer in the hardware composer version we have on the device, we need to integrate it quite tightly together with our compositor scene graph, and this was quite complicated at that particular point. So at the moment, the only thing we're using the hardware composer for is flipping buffers to the screen. But we would like to improve that in the future. Yeah. Can someone sit up towards him? Okay. Yeah. More questions?
Yeah. So, what else are you using Qubes for? For instance, in this device, is it only EGL or? Is it
Okay. So the question is, what else we're using the pipers for in this device? We're using it for NFC. We're using it for OpenGL, as you said before. We're using it for hardware composer. We are not using it for modem, but we are using it for audio hell.
But doesn't Android use Ultra?
Some devices might use ALSA deep down as well, but for the most part, when you're doing a device, you don't want to spend a terribly long time on the hardware. You want to spend time on the things that matters to users, which is the experience. So you can go in and write your own custom configuration for ALSA, or you can take something that works in the first place.
No, I don't.
Yes?
Android seems to be pretty old-grown. Do you see this problem?
Well, it is a problem when we have to deal with system D, which just does not necessarily like that old kernel. So yes, that is a problem. But the fact is that when you're making it, well, the fact that so you're asking if it was a problem that Android is stuck on such old kernel versions, and as I said, it is a bit of a problem when you're dealing with modern Linux software like systemd that always requires extra kernel versions and kernel features, etc. But at the same time, we also have to accept that when a device reference kit from ODM comes out, it will have a certain kernel, and for the most part, it will be very difficult to move it to a more modern kernel as well. We tried to do this in Migo times with, for example, the N900. We had the same people who had made the kernel adjustments to the kernel and asked them to move it to a further like more recent version, and it was a really significantly hard exercise. So generally, yes, please upstream all your code, but for example, for this device, I'm not expecting so much that our kernel will be updated beyond fixes and security fixes. More questions?
One question. What comes to mind is when I use Android and install software, for example, for the Android software, there are no security questions asked. Why did you decide to do this?
I think time is a good answer. So the question was, why are we not asking about the typical security questions when Android applications installed on the device? And I think, honestly, the time has been the issue in this particular case. You need to integrate the security parameters of Android together with the rest of the system, and this takes time. At the same time, the initial people who have bought this device is also people who know how to be secure in their devices. But yes, of course, this is something that should be fixed. So you're asking about how the Jolla security model works, and well, and just to add to that, we are not using EGIS, which is a security framework significantly used to lock down a device completely. So the worst possible answer I can give at the moment is we're using the typical POSIX security model, as in that we have a single user. Some applications might be running into different GIDs and that kind of stuff, but I'm not the right person to answer this particular question. Could be better. Yes?
One of the first slides just said that some actions may void warranty. Just hardware actions, so hacking, or which kind of software action would void warranty?
I don't think, so the question is what kind of actions would void warranty? I would be honestly saying that I don't know, because we haven't had that many cases where we would have to. But in terms of, let's say that you go ahead and overclock your device and you burn out the chip, this is obviously not a problem of ours as such that you did this. But I'm not the right person to answer about warranty policy, sadly.
How much is the overhead of libhybrids when you compare it to just the using?
Okay. Yeah, so the question was, what is the overhead of libhybrids if you just compare it to native, like straight usage? So it depends on what level you're looking at. It is just a function pointer call in practice. There's a little bit of memory cost because we do load in some additional libraries that we might not necessarily would have had to if it was a native driver. But in terms of performance, we are not seeing a significant regression. If you're looking at the really deeper side, there has been a guy that has been developing recently that our wrappers are reduced to something like 3-4 ARM instructions or something like that. So it is possible to get it working much quicker than it is. Oh boy.
When you apply this other fix, the Jolla has quite a good time on battery. How does it work, and which framework for power management or which is the principle of power management using on the SailfishOS?
Okay, so the question is, once we have applied a kind of embarrassing power consumption problem that we had on the device, then we have quite good power management of the device. And the question is that we go into very deep suspend a little too often. A little too often, as in that some cases there might be that we would like to wake up to, for example, to check email, that or for example to execute some timers, etc. And we are not doing enough of that at the moment. We have a QML or engineering framework called Nemo, Keep Alive, that enables you to be woken up at certain times. But it is an effect of seeing that the device basically goes into very, very deep sleep. And some might argue that it's too deep sleep, but some have also played with that. If you just disable the completely deep sleep, that you still get quite good battery still. And this is because it's modern hardware.
What kind of hardware hacks do we have in works for other halves?
So the question was, what kind of hardware hacks do we have in works for other halves? So I think it's better to talk about what the community is doing, because fairly soon we'll be putting out a kind of official SDK for the all half stuff. But the community have done things like hardware keyboard. They have put OLED on the back of the device. They have wireless charging, etc. So there's many kind of interesting projects that are possible to do. Regarding ourselves, well, I can't exactly say what our plans are, but we also feel that we are enablers for these kind of things. Yeah. So the Android compatibility, talking about, I guess you're talking about the applications. It was done by a third-party provider called Myriad. So I can't exactly say in details about how it works. No, it is certainly not open source. Yes. Could you repeat that? Sorry.
As a user, when is the hardware for online synchronization?
So the question is, as a user, when is CardDev and CalDev supported? So there is a togetheryour.com item about this, and I'm pretty sure you probably made it. No, okay. But anyway, that it is something that is being looked at, but I don't have any answers today. I'm sorry. Yes, there's a synchronization framework that you can be using.
You talked about how unlikely it will be to have updates. What about stuff like from, I think it's verified audio?
So the question is what we're planning on updating, and I think I have to end soon, updating specific components, but we are looking into Qt5.2 at the moment, and the updated scene graph, and this will come when it's ready. Let's just say it like that. If you have any additional question, you can try to find me afterwards and ask me some questions. If you haven't gotten a hat already, please come and collect one. Yeah, it's no problem.